share with you guys this morning. For more about my life, my thoughts, you can subscribe to this YouTube channel, of course, where you can follow me at torgrambergstrom.com/haiku. I'll talk to you guys tomorrow.
All right. So that's going to keep playing if I don't stop it. There's a lot of them.
Okay.
Oh, this is a good one. This is a haiku about chip formation. And the video is from class, but not from your class. So for more haikus, you can subscribe to my YouTube channel, or you can follow me at torbjornbergstrom.com/haiku. Where are we? That looks good. All right. Live on YouTube. Echo capture microphone is turned on. Whoa, baby.
That's why.
And now everybody's awake. So should I apologize immediately? Or are you guys now psyched for class? Yeah. That sounded super psyched. What are we talking about today? You should know this. Manufacturing economics. Anybody remember specifically what I wanted to talk about today? Because I think I said this at the end of class yesterday. I think I said specifically. Anybody remember? There was one term I taught this class, and I was pretty proud of myself because I knew all the material and I could do all the lectures off the top of my head. Didn't need to have any slides or anything like that. And I would come in every morning. Yeah, I guess it was morning. It was this time of day, so I would come in, and everybody was sitting in there, and I'd walk in and I'd say, "What's today's class about?" And this is because I wanted to see if you guys were looking at the syllabus. I mean, not you guys. This was a different term, but and I wouldn't start teaching until somebody told me what the class was about, and then I would just do the lecture and I would write stuff on the board and talk about all the stuff I want to talk about. I was very proud of myself because I had realized that I knew the material so well, I could do the lectures without bringing notes with me and stuff like that. And so the end of the term course evaluation forms, like the professor knows the material was like the lowest score I'd ever gotten. Because they thought I genuinely didn't know what the class was going to be about when I walked in. So I know what the class is about. Take my word for it. I'm wondering if you remember what I said the class was going to be about. So manufacturing economics. Anybody remember specifically? What did we do yesterday? What did we figure out yesterday? Yeah. We basically figured out how we understand what our shop rate is if we have a machine shop, right? So yesterday we talked about shop rate. And again, what is the shop rate? Somebody? What is the shop rate? Just a 5-6 word explanation. Somebody? I know. You guys must know. We talked about it yesterday for like an hour. Yes. So we did come up with a minimum. We came up with a minimum shop rate, and that had the assumption that we sold all those hours, right? So we came up with a minimum shop rate. But the shop rate is basically, once you estimate the time it takes to do something, this is the number that you apply to that time to come up with the cost to do that thing. So our shop rate is the number so it's what was the units for shop rate again? It was dollars per hour, right? Right? And so if I understand how long it takes to do something, and I have a shop rate in dollars per hour, I can multiply shop rate, we'll call that R, times time, we'll call that T. And what's time units? What would be a good unit to use here? Hours. In hours, right? And that's hours per ones, right? And then the hours go away, and we get dollars per part. Right? That's a cool thing to know. What do we know about the price per part now? We're a manufacturing company. We're gonna make these parts. We're gonna sell them to you. You've asked us to make these parts and sell them to you. What do we know? If we know how much, what is this? What is this number here? Dollars per part. Is that our cost? Now, is it all of our cost or some of our cost? We know our shop rate. We know the time it takes to do it. This is all of our cost or some of our cost? This is just some of our cost, right? All right, so what's the rest of our cost? There's an eraser. What else impacts the cost of making the part? We've got our shop rate. So cost equals shop rate. What do we call that? R. Shop rate R in dollars per hour. Time times time T in hours, right? What else goes into our cost? Yep.
Material cost.
So materials cost, we'll call that M. Is it plus? M in dollars. What else? Yesterday when we did that stuff on the board, we had materials listed on the thing, and when we went through the thing of costing it, I put this little arrow, and I said, we're going to call that cost of sales. This gets grouped into cost of sales. What else gets grouped into cost of sales? Yeah. The tooling. Oh, we've already used T, huh? I know. Let's make this a lowercase t. It'll make this a uppercase T. What else goes into the cost? Who? Okay, so the quantity. And so this is production quantity. Q, don't forget though, when we do our power estimation, we call Q material removal rate. That's not the same here. So I know, we'll call it QT, quantity. What else goes into the cost of shipping the part to the customer? Yes. So some of that is built into our shop rate and our time for manufacturing, right? So this is the shop rate. This is the time for manufacturing. All right, so you guys have made some parts. Yes. So yeah, there's a shipping cost. So yeah, let's just call that shipping. So we do plus. So we got plus some tooling. We got materials. So tooling's in dollars. Now it's really a percent of the tool, right? Because we don't usually use up the entire tool on the part. Although in my machine shop, sometimes we use up 3 tools on the same part. So it really depends, but tooling's a factor. So the percentage of the tool that's allocated to that part. The shipping is plus shipping. Now the quantity is a multiplier, right? Yeah. Okay, we believe that it's cheaper to make more. Who believes it's cheaper to make more parts? Who believes it's cheaper to make one part? Okay, so no, you keep your hand down. That way I can say nobody believes it's cheaper to make one part. But we believe that it's cheaper to make multiple parts. Why? Because so far with these factors, there's nothing in here that makes it cheaper to make multiple parts, except for possibly we might get volume discounts when we buy the materials. Right? So we might get a volume discount when we buy the materials. We might get a volume discount when we buy the tooling if we're buying more of them. But why is it cheaper? Why do we think it's cheaper? Yeah.
I guess it might take less time because you don't have to like change tools on machines. You don't have to set up the new codes.
Right. So what we've missed here is engineering and setup. Right. And so if we're just making one part, 100% of the engineering and setup time gets allocated to that one part. Right. If we're making 10,000 parts, 1/10,000th of the engineering and setup time gets allocated to each part. And that's why it's cheaper to make 10,000 parts. It's cheaper per part to make 10,000 parts than it is per part to make one part. Does that make sense? And so the setup thing, so if we're any good at this, we only have to do the engineering once, right? And so what's the engineering that I'm talking about? It's not the design, right? Because the design was the designer's job. Yeah.
Creating the cam and maybe like any fixtures that you have to make.
Right. So the engineering that I'm talking about is even before you create the cam. What did we have to do before we created the cam? We had to decide how we were going to make the part, right? Remember we did that whole lecture, we did the art to part thing. We spent a whole bunch of time just looking at the part and figuring out what orientation are we going to hold the part in? What directions are the tools going to come from? Which tools are we going to use? All of that stuff is the engineering. So we've got so you got cam, fixture design. What else? What else? Cam, fixture design. Yeah, tooling selection. Right, what else we got? What else goes in there? Cam, fixture design, tooling. You can't do the cam unless you've designed the fixture, right? So this stuff, programming, it's just programming in general, or yeah, this is programming. So that's the engineering. What's the setup? Goes into the setup. Set the tools, set fixtures. What if I have to build a fixture? What if I have to build a specific fixture to do it? What if I can't do it with my generic fixturing tools? I first have to design it and engineer it. Then I have to make it. And then if we think we're going to get more of these orders down the road, I have to store it somewhere. So I become a fixture warehouse. Warehousing is very expensive. Not necessarily because the pieces, especially if the pieces are small, warehousing is very expensive. Because small pieces are easy to lose. And then you think you have it, and when it's time to go make those parts again, you go to get the fixture, but somebody took your fixture apart and used it for something else instead, and it's not there anymore. Warehousing is expensive. All right, so we got to set the tools, set the fixtures, load the program. Right, we got to do all that stuff. That's the setup. And so this stuff, the setup part, gets attributed to each part in the production run. The engineering, if we're any good, gets attributed to that design once. Right, so say the customer says, we need 200 of these parts every other month. So every other month, I want you to ship me 200 of these parts. So to make the first part, I have to do all the engineering. I have to do all the setup. I have to buy the material. I have to buy the tooling. I have to make one part. Cost to make the first part, I did one a couple years ago. So it was $170,000 purchase order to make 100. Somebody do the math. It's like $526 per part. That was the cost per part. It was $170,000 purchase order. Somebody quick.
How many what?
What was the number of parts? I can't remember.
295.
Right, so almost 300 parts. I think it was 300 parts. I'm just fudging the numbers there. So it's 300 parts, $170,000 to make them, but they paid me $25,000 to make the first part on top of the 300 parts. Because nobody in the world had ever manufactured that part before. It was expensive to figure out how to manufacture. So I charged them $25,000 for the engineering before we shipped them a part. And then $500 and something per part. And that was based on only doing this once because we ran that until it was done. And that's an example of when the facility operated 24 hours a day, 7 days a week for that one part. Have we missed anything here? What do you guys think? Have we missed anything here? How do you make, if you're the designer, how do you make that cheaper? If I'm the designer and I want costs to go down, and let's say we're making prototypes. This class is focused primarily on making prototypes, right? This class is not focused primarily on making production parts. So let's say I need a prototype for my MQP. I need a prototype for this great idea I have, and I'm going to do my Kickstarter, but I need to have something to shoot the video with to do my Kickstarter. Right? Oh, well, yeah, so it could be a collection of different parts. It could be an assembly. In fact, there's hardly ever any reason to make a part unless there's a part that it goes with, right? So almost everything that we make a part, the purpose of the part is to interact with something else. Right? The purpose of this part is to interact with the whiteboard. Right? So all parts interact with something else. So it could be an assembly. It could be a single thing. A name plaque might be a single thing. I mean, it interacts with a desk or a wall if you glue it on the wall. But we have manufactured name plaques for people. That's like a single thing. So if the designer wants to make it cheaper and it's a prototype, I think you got it right here. They've got to focus on reducing the cost of the engineering. Because this is often 3, 4, 5 times as much as the cost of making the part. So your Stirling engines, for example. And this is actually your group assignment 3. Go to Canvas. Canvas.wpi. As soon as I type my password, I'll switch over. Yeah, see? That's why I did it, because I just did my email, my password in the email address line. That's why I didn't switch over yet. Next. Now's the password. Signed in. PC. ME 1800. This term. Assignments. And since I created the assignment this week, for the group assignment. I did not screw up and assign it individually to everyone. I knew how to do this. So it's just assigned to the groups. So you will not have to submit it twice. Probably. Unless I screwed something else up. But you're going to go to this one. Estimate the cost of starting a manufacturing company from scratch. We did that yesterday, right? You're going to make your own assumptions. The purpose of the company, oh, you're going to create a business plan, no longer than 4 pages. The purpose of the company is to manufacture, where is it? Somewhere there's a link. The M1800 Sterling engines. We give you a bill of materials in Excel. So there's the base, there's the Y block, there's the cylinder, there's a piston. These are all the things that you're making in M1800. So you're going to have to figure out your cost of materials. You're going to have to estimate your cost of tooling. You're going to have to figure out these things. And then you're going to have to decide, how many machine tools am I going to build? Or, sorry, buy. How large of a space am I going to rent to put these machines in? And you're going to design the exercise from yesterday combined with this so that you can figure out, what's the question again? This is really good. The cost to make the first part. How much money do you have to spend before you make the first piece? Now you can assume that you're leasing machines, or you can assume that you've gone out and gotten a loan for the capital that you need for the machines. Price points and sales projections, and cash flow projections annually. I think I would tell you to go out 3 years. Some 1 year. Oh, the company starts. The members of your group will operate the business without taking any salary for the first year. For the second year, you can decide whether or not to pay yourself. Just read these instructions here. You will have to make some assumptions. So here you figure out cost, right? What do you tell the customer? Do you tell the customer cost? Everything we've talked about so far has been calculating cost, right? The minimum shop rate that we have to have in order to operate if we can sell all the hours. The cost of the materials, the cost of the tooling, the cost of the engineering. That's our cost. What's the rest of the equation? So profit, right? Because we want to operate at a profit with a positive profit rate. Profit equals value minus cost. How do you know what the value is? Yes. How much the customer is willing to pay, right? We understand that the value is how much the customer. How do you know how much the customer is willing to pay? Well, so we're selling a product now. We're developing this to sell the Sterling engine. So you could look at other machine shops and what they charge for similar work if you're just doing the job shop thing. But actually, in the assignment here, we're building the manufacturing company to make the Sterling engine. So you need to look at products similar to the Sterling engine and see what they sell for, right? Let's pick a price now. Yeah.
Can I ask you a question?
Absolutely.
For engineering and setup costs, so engineering would be a separate value in that equation. So it would be all the costs that we have plus E, and then setup would only be incurred if you're changing the product.
Yeah, so when we expand this equation, I'm going to do it on this whiteboard over here. So we've got shipping. Let's call this part of it the cost of sales. We gotta pick. But all that is one thing, right? So let's COS. It's not really the. If an accountant was watching this video, they would say I'm using the term wrong. So if your dad's an accountant, go tell him that you learned all about cost of sales today, because that's not the right way to use the term if you're an accountant. But we've got that, and that's times quantity, right? What else with that plus? See, it's quantity per production run. So if they tell me I want 100 of these every other month, and it takes us 2 days to make 100 of them, we're not going to leave the machine set up in between. And since we know we're not good at warehousing, we're not going to keep them in stock either. In fact, I had a customer who told me, I need 90 of these parts over the course of this year. And it had to be black anodized, and we don't do anodized in-house. And so the minimum charge for anodizing was $150, the place where I brought them. And it was $150 to anodize one or 100 of them. And so he told me we're going to order 90 of these. They ordered 5. He got hit with the $150 minimum. They ordered 10. He got hit with the $150 minimum. I said, screw it. I'm going to make 100. I'm going to anodize all of them, keep them on the shelf. Because he had already told me he's going to order 90 of them. Never sold another one. Just sitting on a shelf in my office. Right, so, so you got this quantity, and so this is plus setup. Right, setup, wait, no. Setup happens once per each quantity. Plus, but that's the setup for this production run. Plus engineering. If we do an identical production run in the future, we don't have to add the engineering because we already did it. To our cost side. Now, we've already, at this side, we've determined what the value is though, right? Because the customer has paid us. So this might become profit in later runs, right? The fact that we had to add that in, or we drop our price over time. And so what I'm quoting, price goes down based on quantity because it absorbs that engineering. So is that where are we? What are we doing? We're talking about project. You got that? Any more questions about the project? Do next, not Friday, a week from Friday, but not the last day of the term. So that you're well done before the last week of the term. Is that cool? So you're not working on an M1800 group project the last week of the term when you'd rather be studying for finals for some other class? Who's ever had a class where the professor extended the deadline for the project past the last day of the term? Raise your hands, be proud. Be proud. Did you love it? I always accepted the extension. I always then shifted it off to the side and did the stuff that was more important because it had a faster due date, right? Anybody done that? Yeah, anybody been sitting in their room, in their apartment, in front of their computer, trying to finish that last project when everybody else in the house is having a party? Yeah, I hate it when the professor extends the deadline beyond the end of the term, so I won't do it because that is just not fair to anybody. Okay, get that with time. Perfect, right on schedule. This is prototype parts. What happens when we're going to make the parts as fast as we can possibly make them? Because our customers would like to buy them faster than we can make them. Same? Do you use the same processes? I co-advised an MQP a couple years ago. Group of WPI, it was a combination of mechanical engineering students and industrial engineering students. So and I love to do those kinds of MQPs because that's how we work in the world, right? We don't get to go be a mechanical engineer and just do mechanical engineering. We have to actually interact with other people. You saw the thing when the Bobs were asking him, what do you do here? I'm a people person. I talk to the customers so the engineers don't have to. Yeah. So it's good as engineers to get experience talking to people. Even if you only look at their shoes when you talk to them, you get to have those experiences. So I love those kind of MQPs. So this MQP is a local manufacturing company. In this company, they were making a part. I'm trying to think if the material was steel or aluminum. but just a common material. They had 7 high-end Mazak machine tools making this part 24 hours a day, 7 days a week in their factory. And that was just one component for the thing that they sell. So 7 machines working 24 hours a day, 7 days a week, making these parts, shipping them out. And it actually was 6 doing full production. The 7th one would be operating when something was down for maintenance or for a switch out. So it was really 6 machines running full time, but there was out of 7 machines, so they would move them around, they would fix setups, things like that. Sometimes it would be all 7 running, but they needed 6 machines running. The company had realized that although they had 7 of the same machine tool model number, so the same exact model, they weren't all purchased at the same time, and they weren't all installed at the same time. And it was over the course of maybe about 5 years that these machines were purchased and installed in the shop. They had 7 machine tools. So the time thing in our, we had our time up here, right? Oh, red. Time was one of our factors, right? And we multiply our time by our shop rate. So even when you're doing manufacturing in-house, for accounting purposes, you have a shop rate. Now, it should be lower than what the external shop rates would be because you don't have all the overhead that your shop has to absorb. But, so we've got time, right? We multiply that by our shop rate to figure out the cost of making the part. And so what is this time? Because it's not the setup, right? We separated setup out. We separated engineering out. What is the time? It's the cycle time. So this time equals, oh, except I used the lowercase t, didn't I? That's the cycle time. In a spree, can you calculate a cycle time? Anybody know this? You can. If you've got your programs all done, and you select all the operations in the project manager, and you open the properties window, it will tell you the time that it estimates to do that cycle. And it knows this, right? Because it knows the feed rate, and it knows all the distances that it has to move. The variable there, there's some setup stuff that you do. You have to tell it what the rapid speed is, because it also knows how far it's going to move in rapid. And you have to actually tell it how far the tool changer is away from the workpiece and stuff like that. But you can get a very accurate estimate of the cycle time just from the CAM software. And so that's what you want to do when you're estimating the cost to make these things. So that's the cycle time. So they had 7 machine tools making the same part, same program, same model number on the machine tool. They had 7. They also had 7 cycle times. In the variance, what's this mathematical symbol for variance? This would be really cool if I knew that and I drew that symbol right now. There's like a mathematical symbol for variance, isn't there? Anyway, the variance in cycle times was about 50%. The fastest machine made the part 50% faster than the slowest machine. Same model number, same program, same G code. Not just like same CAM file, same G code. So the purpose of the MQP was to figure out why. And they were able to figure out why within the first month or so, because all those machines were installed differently. All the X, Y, Z motors and the spindle motors and all that, those are servo motors. They all are tuned differently, so they had slightly different accelerations chosen, slightly different decelerations chosen, things like that. And not all the fixturing was identical. So some of the fixtures were a little bit taller, some of the fixtures were a little bit shorter. When it was the taller fixture, it would take longer to get there. Not all the operators were identical. Some of the operators would chicken out and they would reduce the rapid speed on the first couple parts just to make sure they hadn't screwed something up when they changed a tool or something like that. Some of the operators would go full speed first time out. So it was kind of easy to identify the root cause of the variance. But then the next thing that they did was they tried to optimize the programs to minimize the cycle time. They want to minimize the cycle time because they have a customer that wants the parts faster than they're capable of making them. So if we wanted to minimize the cycle time, what are the kinds of things that we would want to do? And this is in a case where we're doing high volume production. The other thing we look at is, do we want to minimize the cost for doing that particular cut? What are the things we want to consider? We want to minimize cycle time. So remember, we're running this 24 hours a day, 7 days a week, with tools wear out. So we're going to consider things like tool wear. What else are we going to consider? If I told you that I could say the same tool, or a tool that could do the same thing, but it would cut the parts twice as fast for the same life. How much more is that tool worth? I want you to ponder a question here. What's the cost of changing a light bulb? If you buy 2 light bulbs, one of them costs 99 cents, the other one costs $6.99. Bulb A, the 99-cent bulb lasts 10,000 hours. Bulb B, the $6.99 bulb lasts 20,000 hours. Yep. Same light quality. Right. People ask me that question. Well, is one of them better light? Same light quality, to the best of your knowledge. Who wants bulb A? Who wants bulb B? 2 of you? Bulb B? Stand up if you would pay $69.99 for bulb B. Nobody. Usually there's a brave soul that would pay $69.99 for bulb B. Who didn't vote? Why not? Pretty low threshold for paying to vote here. You thought maybe there's a bulb C? Why didn't you vote? Not to call you out, but I'm calling you out. Why didn't you vote? Was it good? Okay. Did I send it? Okay, good. I would hate to frustrate you in Slack. You didn't vote? You voted. You changed your vote?
I didn't.
No, you didn't vote?
You don't know the cost of replacing that light bulb.
Yeah. Yeah, so I actually, years and years ago, I used to operate rental apartments in this area. We had several. Who lives in an apartment off campus? Yeah. Have you ever come home and had the light not work in the front hallway? No, never? Used to happen to my tenants. And it would happen to my tenants, and then they wouldn't tell anyone that the light didn't work. Who's ever noticed that something's wrong and you don't tell anyone? Yeah. Yeah, we've all kind of done that, right? Right? Anybody ever walked by the car in the parking lot that had the lights on and think I should write down the license plate number and then go tell the people in the restaurant that this car is, and then you don't do it? Anybody ever done that? Yeah. We all do that. So my tenants would never tell me that the light was out. I would go there in the daytime and there was windows. So I wouldn't know that the light was out unless they told me. But then Sunday afternoon, they would get pissed because that light's been out for 2 months and I haven't fixed it. They would call me. And I'm having dinner with family, friends, my kids, whoever, right? Sunday afternoon. Like, all right, I'll be over, I'll fix the light bulb. Because I did learn that when you're a landlord, if they call and complain, you have to show up right away to look at it. They have to believe you cared. Now, you might take 2 months to fix whatever they complained about, but you have to show up right away to look at it. I had learned that over the years of being a landlord. And so I would go over, be like, yep, light bulb doesn't work. I should have some light bulbs out in the truck. Oh, no. I emptied out all the light bulbs from the truck. I put them back in the barn. But that's okay because I need a ladder anyway. So you go back to the barn, looking around for those light bulbs. Where the hell did I put the light? Damn it. Well, let's throw the ladder on the top. Go to Home Depot, buy some light bulbs. And at the beginning, man, I bought some 99-cent light bulbs. Because I wasn't just a landlord, I was a cheap landlord. First of them all. I'd buy the 99-cent light bulbs, and they would fail more often. Because even if they said they had a life of 10,000 hours, they didn't always. They would fail more often. And then you balance that. It's always the one at the top of the atrium that doesn't work. Because if it was one of the ones that they could reach, they would have just changed the light bulb if they actually cared. So you balance that ladder up there, risk your life, get up there, change the light bulb, come back down. I calculated once how long it would take me to do that. And at the same time I was running those rental properties, I was also selling my consulting time as an engineer. And I realized that it cost me well over $1,000 to change a light bulb if I could have sold that time as a consultant instead of a light bulb changer. And I would buy the $69 light bulb every time as long as it was guaranteed to last twice as long. So we're going to go from that. We're going to spend a little bit of time tomorrow talking about the process to optimize cost per cut. And so this is when you're in that situation where you've got 7 machines making the parts as fast as possible and you can't make them as fast as your customer wants them. We're going to talk about the process for how you optimize that. And then we're going to finish up talking about metrology and the last bit of quality stuff that I want to talk about. Yes, that's tomorrow in AK 3 whatever 233 332 whatever the classroom we are in. Is the end of today the right timing on that? Okay, he said it is. I would have been more generous. Yeah, it's actually one section that's going to be shifted in lab. We'll figure it out. Yes, the cam is still due on Friday, but if you don't get it in on time, then we'll work it out with you. But I don't want to change the due date. That confuses everybody. Okay. Oh, okay. There was a specific group that didn't submit the right thing or something. Got it. I told you about the group last A term that submitted the wrong assignment. Did I tell you that? Well, this time we didn't. We gave you both assignments, and you got to pick which one you wanted. Yeah, I don't think they did it on purpose. A term. I created the new assignment because we had shifted the order of the lectures, and we changed some of the questions, and now you guys got to choose which one you wanted. But in A term, there was one group that submitted the old one. Everybody else submitted the one that we assigned to them. One group submitted the old one. And not only that, it was so perfect that I believed that it was my grading template. And somehow they had found my grading template and then resubmitted it to me. And I wanted to go find my grading template so that I could compare them side by side. And I couldn't find my grading template. And I started to realize maybe I didn't actually have one that was as good as the thing that these people submitted. So I said, well, how could they possibly have done this on accident? I'd like to believe that it was not malicious. And I Googled M1800 group assignment 2, and of course, the old one was the one that would come up if you search for it in Google, not the new one. So I called them into my office. They didn't know why. All they knew is they didn't have a grade yet. And I said, you guys submitted the wrong assignment. Talk about deer in the headlights. They were either really surprised or they realized they were caught. Because you couldn't tell. The deer in the headlights could have been either one. I said, how did you find the assignment? He said, I Googled. And I said, good enough, we're done. We'll grade the one you handed in. The one they handed in was actually harder at the time because we hadn't gone over the stuff in the lecture yet. So, yeah. What's going on? We got 2 more weeks? Ish? Like a week and a half ish? Something like, is it 2 weeks? We have a full week? We have a partial week and then a full week?
Yeah.
So there's 2 full weeks left?
After this week, after next week.
Yeah. So we get 2 full weeks left. I hope you guys have gotten stuff out of the class that's useful. If you haven't, and you don't do something about it between now and the end of the term, it is not my fault. So if you want some different usefulness out of the class between now and the end of the term, you need to tell me. Because if you took this class, didn't get what you wanted, and didn't complain about it in advance, it's not my fault you didn't get what you wanted. I'll see you guys tomorrow in lecture.